each other, and and then ultimately show how AI pulls it all very neatly together. So
Do you need a mic?
I have a mic. It doesn't?
Mic.
Oh, okay. Has it started recording?
Yes.
Nice. Sorry. Okay, cool. It's not loading up. It's okay. Okay, originally I wanted to do like I'll draw as I go, but I think now I have to type as I go. Let's just use Okay, cool. Okay, font size. Right. Okay. Can someone explain to me what IoT means? What's your understanding of IoT? Show of hands. Volunteer. Yeah, but what does it mean? What does it mean if, let's say, I'm a startup and I tell a venture capitalist that, I run an IoT startup? What are they expecting from me?
Wearable device provides some data.
Yeah, correct. So I think essentially what IoT means is that I have a lot of sensors, right? And then these sensors are collecting data, and then it's sending all this data to the internet, which is essentially the cloud. So that gives us cloud computing, right? Which is another buzzword as well. So previously they were like, okay, sure, let's come up with as many IoT devices, and IoT devices that monitors like your body, like your heartbeat, whether you are going to, that you're breathing heavily, how well you sleep, and all these kind of things. People have been trying to collect all this data and sending it to the cloud. So when you pair up IoT with cloud computing, what kind of problem arises? Anyone? Anybody? Let's keep this conversational, by the way. It's just a bit strange for me to just talk to one way. Security, right? Okay. So we had the problem of, let's say, cybersecurity. What other kinds of problems do we have?
Privacy.
Sorry?
Privacy.
Privacy, I think that comes under cybersecurity. Sorry?
Standards.
What kind of standards?
Like if you send a command, this device reads it the same way as another device.
I don't quite understand. What do you mean?
Like a unified platform that every device can adhere to.
So how each device talk to each other, the communication protocol, right? So I think in terms of communication protocol, we can kind of classify it as network bandwidth, right? Also, it falls under the whole section of network bandwidth. Communication protocol, not such a big problem because you can always modify the protocol. But in terms of network bandwidth, to say that, if I am sending every single tiny detail to the cloud, is it efficient? For example, if all, like, okay, your internet bandwidth, right? You can only send that much data per second. You can't send unlimited data. So what happens if I have a sensor strapped to my wrist, one to my head, one to my feet, one to my arm, and you want to send everything on the same network bandwidth? You can't have a clock up there, right? So then we have the network bandwidth error. It's like, yeah, so much data, you're collecting so much data, but then can you actually send it fast enough to the cloud to actually process it in real time to give you the results back? So that's another problem. What's another problem that you can think of? Scalability? Yeah. So okay, when we talk about scalability, this one's a little bit tricky. We are looking at how I would phrase scalability. It's kind of like centralization, right? You are sending everything out to the cloud. You are trusting, let's say, Amazon to do all the processing over there. So how it works is that, there is a whole server room of big computers doing all this data processing, etc. It's all in a central location, somewhere that, totally far away. So the problem with that is that what if, somebody hacks into it? What if that server, fails, and what if it falls, right? So that comes the problem of decentralization. Okay. So decentralization. So when you talk about decentralization, we're talking about decentralization of data and decentralization of computing power, right? So if you have decentralization of computing power, it means that, instead of having everything processed in one place, you can have it maybe a little bit here, a little bit there, etc. As for decentralized information, decentralized data, if you don't have like one mega place that stores all your data, it's kind of like distributed everywhere, it becomes ideally safer, right? So okay, with IoT and cloud computing, we have these three big problems. So out of these three big problems, it now gives rise to new technology, right? So now we're going to look at the new buzzwords that solve these three big problems. Okay, so from cybersecurity and decentralization, what do we have? We have blockchain, right? Anyone here familiar with blockchain technology? So you have things like, okay, so anyone can explain to me blockchain? In like the most simplest layman term, in like a one sentence kind of thing.
Database.
Correct. So decentralized database. So the idea of blockchain is that I store a little bit of information with you, and I store a little bit of information with you, and a bit of information everywhere, and then like essentially becomes safer where the other people can actually verify your data instead of having like this whole big governing body doing all the data hogging. So the blockchain is kind of like literally blockchain, because like whatever, you have a chain, you have blocks of information, and then you append to it, and then you have a blockchain. And then of course, another buzzword from blockchain that you might hear about is like hard forks, which is kind of like you split the chain into like two chains, etc. But let's not go into that, okay? That's not what I'm here to talk about today. But just to give you an idea of blockchain, what uses blockchain? So things like cryptocurrency, bitcoins, Ethereum, all these kind of things, where they're kind of like, they use blockchain technology. So blockchain is another buzzword that you're gonna hear. So as long as you tell like an investor or like, oh, I'm doing a blockchain startup, okay, they're like, here, take my money. So it's a very hot topic that arises from cybersecurity and decentralization of very well put database. Another thing that arises from this, so blockchain is kind of like the concept of it, right? Where you develop, it's more of the software side of things on how you store the data, etc. What about the computational power of it? So that gives rise to this thing called fog computing and edge computing. Okay, anybody knows the Okay, wait, sorry, I think I asked this. Only one person knows what's edge computing. Okay, anybody here knows what's fog computing? Raise of hands. No? Okay, never mind. Okay, the gentleman over there who said, about edge computing, could you just very briefly share with us what's your understanding.
Well, it's just moving your processing power out to the edge of the network as opposed to synchronizing some data centers.
Very well put. So what he said just now is to move your data to the edge of the network, right? So edge computing is really saying that, okay, you have your, I'll talk about fog computing and edge computing interchangeably. Then later I'll tell you the difference between the two. So the cloud is here, right? You're sending, right now all the data is stored in the cloud. And then you have the source of generation of your data. So that's your IoT sensors, etc., where the source of data. And what's in between the source of data and the cloud? So to put a device right smack in the middle, ideally closer to the edge of the data generation, the device generating the data, that's your edge computing device. So the idea of an edge computing device or a fog computing device is that it's a physical hardware platform that actually aggregates all the nitty-gritty data before sending it to the cloud. So what does that mean? It means that, number one, it maximizes the network bandwidth, right? Because if let's say I want to do real-time processing, to send the data all the way to the cloud, it takes maybe a few seconds for it to go there and then it come back. So in terms of time-sensitive decisions, in governing the security of, let's say, the airport, where you need to act in terms of milliseconds, or in the factory process line, where everything is being manufactured and things like that, and flying past in terms of your packages, you cannot afford to be like, oh, 1 second here, 1 second here, 1 second here. It needs to go in real time. So that's the benefit of having an edge computing device. So what's the difference between fog computing and edge computing? Okay, this is my interpretation of it, okay? So fog computing is, some people, okay, it's quite controversial, this thing. Fog computing is, in my opinion, Cisco's way of saying that, no, it's not called edge computing. We came up with the concept of fog computing like how many years ago? We have right over it. So fog computing, the term was literally invented by Cisco. Nobody else, just Cisco. Edge computing is what the general public agrees on calling. So usually you hear the term fog computing is usually someone that's brainwashed by Cisco, okay? So why called fog computing? Here's my conspiracy theory, is that you have a cloud, and then you have the source of your source of data generation. What's slightly lower than the cloud is the fog. Okay, never mind. So, I would really prefer if you call it edge computing. So edge computing, if you've been following the media, it's only recently gotten traction in the last 5 months. So Forbes magazine calls it like the next multi-billion-dollar industry, how it suddenly and silently crept up and it's going to be the new thing. Whichever IoT or AI startup that has edge computing would have an edge over the rest, okay? So edge computing, in terms of aggregated data. So what we actually do at SmartCow is we build our own edge computing device. So I came up with the idea of edge computing like 1 year ago, and that buzzword term did not exist. So I invented my own term called Distributed Intelligent Network System, which is quite a mouthful to say. So now when I go into meetings, I just tell them, oh, we built edge computing device, they slightly get it. So the benefits of edge computing device, because it's decentralized, right? You address the problem of scalability. You can connect, think of it like Hydra, with one device, one edge computing device connected to a lot of sensors, and then this device connected to another edge computing device, which is then connected to a lot of sensors, and then that device connected to another device with a lot of sensors, and so on and so forth. So what you have is your own distributed intelligent network system, i.e. isolated computational system. So I've been in talks with, let's say, the government in Singapore, etc., to actually form the whole distributed intelligence system for various projects. So what's the benefits of it? Is that it's very isolated. So all the processing happens on these devices itself. It doesn't get sent to the cloud. You may not necessarily connect it to the cloud. You can. So what's the limitations? Is that it's scalable in terms of you can connect one device to another. So if let's say one device has 1.5 teraflops, you connect it to another device, it has 3 teraflops. But in terms of analysis of historical data, right, it's not that good because it's limited to that processing power and it's limited to the onboard memory, right? So that's the limitation. So in terms of, let's say I want to archive a lot of this kind of data and like the video network, like if you're setting your cameras to like 60 frames per second, you want to store every single data, you cannot just rely on the hardware itself on site. You need to kind of like send it elsewhere. So that's where the cloud computing comes into play, high performance cloud computing, so on and so forth. So you got a good idea of edge computing. So talking about the hardware, who here actually knows about DNA computing and neuromorphic computing? Have you heard of neuromorphic computing? Okay. So these are like new buzzwords that you're gonna hear probably in the next 1 or 2 years. It's starting to get traction already. Right now it's in the R&D phase. Morphic computing. I'll just quickly go through with you so that when you actually hear about these terms, right, it doesn't come as a surprise. All right, okay, wait. Before I talk about neuromorphic computing and DNA computing, under edge computing and fog computing, you have 3 things, okay? You have another 3 buzzwords that you're going to hear very often. First one is GPU. Next one is FPGA. The other one is ASICs. All right? So right now, the buzz is GPU. ASICs is more for blockchain, mining. All right? Okay, so GPU, anybody knows about GPU? I'm sure the gamers, most guys. Okay, so GPU is pretty much, you have your CPU, which does your whole computation, right? And then you kind of like outsource it to the GPU. So one is the master and one is kind of like the slave, right? So you outsource the task to the GPU. The GPU is very good at parallel processing. So it can actually process, imagine like instead of one processor doing the work, it spreads it out into like multiple tasks, so it can assign different threads within the GPU to do it. So it actually happens what we call parallel processing, and then once it's done, you bring it back to the CPU. So previously, AI and neural nets have existed for since my parents' generation, but it's only because of the recent breakthroughs in hardware computation that it can actually power all this kind of data processing in real time. So the GPU, right now the leader is NVIDIA. Of course, they're facing tough competitions. More people are coming into the game, the big boys. So like ARM has like ARM Mali. You have AMD with their Ryzen, and like a lot of more players are coming into the GPU space. So GPU, I think right now is number 1. Although people are exploring FPGAs now in terms of hardware things to do AI computation. So FPGA, in my opinion, is very tough to do. Not worth going into yet if let's say you're a startup. Maybe as a researcher it makes sense. But FPGA, because FPGA is super duper hard to program on. And to be able to program FPGA and to be able to program deep learning stuff, you kind of need to be competent in like both of them, and it's very rare to even just find someone competent in programming deep learning stuff. So FPGA plus deep learning is just like a really, really bad combo. You can't really find this talent in the market right now. If you can, it's very rare. And then ASICs, it's kind of like a custom board that's only built to do one specific purpose, right? So in terms of, let's say for blockchain, like in terms of Bitcoin mining, have you heard of Bitcoin mining? It's people, trying to mine Bitcoins to validate stuff. So of course, when you want to validate it, it's a lot of by brute force kind of attacks, and you just a lot of processing power. That's why people kind of have like Bitcoin mining farms, based in China mostly. So they build specific hardware just for one sole purpose, which is kind of like Bitcoin mining, etc. So you can also build a board with one sole purpose to perform AI. But the thing about the A6 board is that once it's done, it's done. That's the only purpose. It's like, what is my purpose? Just that. It's quite sad, but then it's possible. So these are like some buzzwords that you're gonna hear for the hardware architecture for fog computing and edge computing. So as promised, I'll bring you very briefly through neuromorphic computing and DNA computing. Okay, this is really very avant-garde. To be honest, no legit product out there in the market right now, but a lot of the research is within, is it IBM? I think it's IBM. IBM True North, is it? Or True Sense or something like that. Okay, the idea of neuromorphic computing. So A-Star in Singapore has been looking into it. I have a friend who was leading the department for neuromorphic computing. So neuromorphic, when you talk about the word neuromorphic, neuro, it reminds you of something like in your brain, right? Your neurons in the brain. So the idea of neuromorphic computing is how do you actually replicate the way your brain works, the cells that in your brain, how it works, into computer. So it's a bit like neuroscience, right? Is it called neuroscience? I think so. So the idea is every single cell, in this case hardware device, will have its own processor and its own memory. So right now, if you look at a computer, it's like, okay, there's one processor here and then there's a memory here, but it's not the same thing. So a very vague concept of neuromorphic computing would kind of be like how you would scale with edge computing devices. It's like you have one edge computing device connected to another edge computing device and then it's here and there. I think that could be considered as a very early stages of neuromorphic computing because every edge computing device has its own processor and it has its own memory chip, right? So that being as one single node talking to another node with its own processor and memory is kind of like a, like one brain cell talking to another brain cell. But I mean, in the most ideal situation, every single thing within a chip, a neuromorphic chip, right, would have it like that. So not so big, but like it's own, like it's all like made into a small little silicon chip, right? So that's a really interesting concept of neuromorphic computing. Nobody actually really nailed it down. Was it IBM True North or something? You can Google it to find out more. They have been the leaders in terms of this neuromorphic computing, but they say that they have it, but nobody actually seen it. Nobody outside of that company has seen it. So it's like you don't know whether they're lying or they're not lying, just to push up stock prices. Okay, the next part, DNA computing. DNA computing has been tied to the concept of memory, right? Let's talk about memory storage, data storage. People have been obsessed over how you store data, right? I mean, the last times you've been stored, like one big floppy disk can only store how many bytes, and then now you can have like hard drive, SSDs, and then now you have M2 SATAs and stuff like that. DNA computing pushes it one step further. Okay, so if you recall, DNA, in your DNA cell, your helix formation, you have the AT-GC pairing, right? So A can only pair with T and then G can only pair with C or vice versa. So because there's only AT or GC, very much like binary, you have 1 0 or 0 1, right? So it becomes very straightforward. It's like, okay, if let's say you can encode the AT-GC pairing into ones and zeros, because it's either that or it's not that, right? You can actually reduce the size of your computational whatever, right? So it's like, imagine if one drop of blood, you can really store so much information because there's tons of DNAs within like a single drop of blood. But of course, right now we are not testing it with blood. They're testing it with liquids, gels, and fluids. So it's very interesting. They have already done DNA computing. It's already like out in the media. You can research about it. It's done. The thing is that it's very expensive to be able to do DNA computing right now. It's just a matter of time, I think, that they reduce the cost of DNA computing in terms of the brain, and then you'll make it like more accessible to people. So it's just a matter of time, I think, that it becomes a public thing. But yeah, it's a very interesting topic. You can research on it. Yeah, give it another maybe 5 years or something, then it hits the public market, I think. So of course it needs to be biologically safe and stuff. So yeah, okay. So how do I reduce this size? Okay. So we have all these buzzwords. Now let's look at the data processing side of things. So with IoT, we are collecting a ton of data, right? Okay. I'm gonna just draw it out here again. Just the gist of it, because we're lacking some space. So now let's talk about data processing. We have a few more buzzwords, and that would be data mining, your IoT which generates the data, and of course, how can we forget our dear open source data, right? Everyone loves open source. Okay. So we have a ton of data coming in. The next big thing is kind of like, okay, great. How do we process the data? So when you talk about data processing, a few things come into mind, right? I'll just put it all here. First thing about data processing. Can you do it in real time? Sometimes real time doesn't really matter, right? If let's say I want to just monitor some data and then look back at it in like maybe 2 weeks or something like that, some people don't really care about real time, but it is a buzzword, definitely, whether you can do it in real time or not. And then also you're looking at the integrity of the data processing, the integrity of it, and so on and so forth. When I talk about integrity, I'm talking about a little bit about the security of it, and you know, since you're handling so much data, whether it actually get lost, and the most important thing about data processing is, can you get meaningful data out of it? So with data processing, you have your new buzzword, which brings us nicely back home to artificial intelligence. So, I'm sure you heard the terms like big data processing, where people come up with, programs to try to make sense of data. Make sense of data with Excel sheets, with proprietary algorithms, with data visualization. There's a ton of startups just focused on data processing. So artificial intelligence is just another branch of startups that do data processing. No big deal, really. So I'm going to clarify some things about artificial intelligence, because right now it's a big hype. People seem to think that it's black magic. They think that it's going to take over the world, but I mean, it's not. One thing I realized is that whatever concepts that men don't understand, they think it's black magic and it's going to take over the world and go like, oh, it's God. But honestly, it's not. Okay, so a lot of artificial intelligence, you're going to hear things like, it's rule-based systems, logic-based systems, etc. A lot of it is still rule-based systems. So yeah. Okay. Okay, anybody knows the difference between machine learning and deep learning? No? Yes? Yes! Correct. So artificial intelligence is this big umbrella, right, that says that it's artificial intelligence. It does its own data processing and stuff like that. It can do supervised learning and unsupervised learning. So artificial intelligence is kind of like the big umbrella of things on how it can actually process by itself. And then under artificial intelligence, you have machine learning. So machine learning has existed since my parents' generation. It's a lot about feature-based extraction and things like that. And then under machine learning, you have deep learning. So deep learning is a subset of machine learning, which is a subset of artificial intelligence. Does that give you a very good idea? So artificial intelligence is a very broad and generic term that we just call this whole genre of data processing. It has been around for a very long time. A brief history about it is that we have gone through 2 AI winters. So what's an AI winter? So in the past, during World War II, you have heard of the great Alan Turing and stuff like that, the Turing tests. So the Turing test, like way back in the day, was that if, let's say, I am able, last time they have these like machines where you tap, 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 and then you're talking to somebody else, but it prints out in like a carbon paper, a little bit like a typewriter kind of thing. So it's a little bit like a combination of a typewriter and a fax machine in real-time conversation with the other person. So in the Turing test last time, it's kind of like you tap, tap, tap. If you are unable to distinguish that you are chatting with a computer, and you actually think that it's another person, then that passes the Turing test. So that's really the early stages of artificial intelligence in terms of natural language processing. So NLP, that's another buzzword under the subset of AI that you're going to hear. So natural language processing, what we have now is, of course, chatbots, right? When you type on like a help support kind of thing on the government page, there's a chatbot replying you, or in terms of your Siri on the phone, etc. Those are under the classification of NLP. So back then, Turing time, you have this whole boom of AI innovation, and then you have a ton of movies that come out about AI, like Matthew Broderick in War Games and stuff like that. And then the problem happened was that the problem with it is that it was actually making good progress, but when the VCs heard about it, they were like, take my money, take my money. And of course, when they say take my money, they say like, okay, promise me something. Promise me that you're gonna build this and this and this and this and this. And the startups kind of overpromised in terms of the things that you can do. It's kind of like, the VCs who were investing in them did not have a very clear understanding on how the technology worked. So the startups back then ended up overpromising, and of course, when they didn't deliver, they put out all their funds, and then winter, just like nothing, right? And then after that, a whole new wave came up again. I was like, okay, no, AI is still good. Let's revive the whole AI movement. And then the VCs again was like, take my money, overpromise, winter again. So man didn't really learn from its mistakes twice. It went into AI winters. You can actually Wikipedia history of it. So right now, are we going to go into another AI winter? Because now there's so much hype about AI again. I personally feel no, because the guys spearheading the whole AI movement are people who actually know what they're doing. Yeah, who know what they're doing. So there are people leading the frontiers of the AI innovation curve. It's kind of like Google, Facebook with their open source projects, and now a lot more people have a clearer understanding of what AI is, how AI works. So later I'm going to teach you how to talk to an AI geek. You don't tell them, oh, build me this, build me that, but how do you actually talk in terms of AI terms? So yeah, that's a brief. Okay, did I miss out anything? No, okay. This is a very nice segue. Okay, how do you actually speak AI? Okay, let's not go into the techie part first, but let's talk about what it can do and what it cannot do. So, let me give you a very good example of what it cannot do. Okay, it's already, in terms of what, cannot do. I went into a meeting with Sir Cisco, the head of their innovation department. Oh shit, I shouldn't say this. Okay, cannot, scrap it. Okay, right, NDAs. Okay, I went into a meeting with this very big short guy. This is a different case, okay, by the way. So I'm a meeting with a very big short guy, and then he says like, hey, Annabelle, I want you to replicate the Amazon Go store in Seattle for me. You know, the one where you actually can like pick up a bottle of water and just walk out of the shop and then it just builds your account, you know. They use a combination of sensors and computer vision and all these kind of things, right? And he says, I just want it with computer vision. Oh, by the way, right, computer vision is a subset of artificial intelligence. The official term for computer vision is IVA, Intelligent Video Analytics. So purely with IVA. And I was like, me, just me. I was like, yeah, just you. And I was like, you know, Amazon is a very big company, right? With like thousands of employees and like their business is pretty much gathering data. I was like, yeah, I know. But you see, they didn't come up with this overnight. They've probably been working on it for the past 10 years, and in the past 10 years, they probably did not have the innovation that we have today. You are really the frontier of Singapore's AI scene. I think you can do it. And I'm like, right, and you just want it with computer vision and nothing else. I was like, yeah. I was like, nah, I'm not gonna do that, right? I mean, even so, like the user experience of it, right? If, let's say you have a camera pointed there right in front of it. I mean, there's limitation with camera. I'll talk about that later for IVA. But even so, it's like how do you actually go into a meeting and request for an AI technology stuff? It's like very often it's like not, yeah, you just meet people who don't know how to speak AI. So the thing about how do you speak AI? As an AI practitioner, I feel that it's your responsibility to actually be the one innovating the products. You cannot rely on the person from within the company to say, build me this, because most of the time when you tell them, hey, what do you want? They'll be like, oh, you sure you want to ask me what I want? I want the moon, you know. It's a very conceptual idea of AI that they have, but when it actually comes to the deployment of it, they have no clue on how it works. They think it's some sort of magic that, as long as they see in a movie, it can be real. And like with any technology, it has its own limitations. So the core essence of AI, when you talk about project management, you're looking really at the features, right? So for example, if I have a model that is trained in facial recognition, something simple that we are familiar with, facial recognition, to be able to recognize a person's face, it is not the same as a facial expression model, right? So yes, it's still looking at the face, but facial recognition is pretty much saying that, hey, I am able to compare your face with the criminal database of face. I'm able to distinguish that your eyes are here and your nose is here, your mouth is here, and how big it is probably. And maybe based on facial recognition, I can also, because by taking the average, the average distance between two people's eyes is more or less the same, right? Using that as a scale, I can actually estimate your height. It might not be the most accurate estimation, but it's a good estimation. So that's a plus feature in terms of height. That one's not really deep learning, but it's more of like a data processing, right? Which is what AI is pretty much about. So the actual model, facial recognition, is one model. Facial expression is a different model, right? To be able to detect that how many percent happy, how many percent sad, how many percent angry, that's a totally different model. There are two different features. So to just say that I analyze faces with deep learning or AI, it's too generic. So in terms of features, you need to be very specific. So when you say, okay, if let's say I'm a startup, how are you able to, if I am the end client and there are 10 different startups in front of me that says, I do facial recognition, how do I know which startup to go with? Who do I actually pay the money to? I'm not going to pay to all 10, right? And then have like 10 duplicates of facial recognition software. How do I actually choose and decide that this startup for facial recognition for AI is better than the other one? So, of course, different companies have their own different ways of judging. For me, I judge it based on just two criteria. The first one is, how accurate is it? So accuracy would mean that, okay, let's say if the camera is here, I scan it from here, it's able to detect, right? But if let's say I turn my face a little bit, like maybe 45 degrees, I'm still able to recognize my face. Also, even if it's frontal view, etc., how many percent, like what we call confidence interval, like how much guarantee can you give me that, it is actually my face and not somebody else's face? So accuracy is a very big thing. The next one that I judge it on is latency. So latency is pretty much, you want it in real time, especially when you're looking at facial recognition, you're comparing a criminal database and you're having monitoring MRT station with like thousands, maybe hundreds of thousands of people walking across all the MRT stations at the same time. You need to be able to do it in real time. So when you talk about latency, usually the thing that gets compromised is the quality. So quality kind of like, okay, the thing when you do IVA is that you have to pick your cameras. Sorry, I sidetracked a bit about cameras. You have to pick your cameras very carefully. The reason being is that if your data input from the cameras, the pictures that you take, is already not clear, it's not readable, like let's say the lighting condition has shadow or something like that, right? Or it's a bit blurry. If your data input is already not clean, I cannot guarantee 100% accuracy or something like that. Or I cannot guarantee, various other things. So if let's say I want it to have real-time computation in terms of latency, usually the thing that gets compromised is the size of the file, because they don't have the data, the computational power to process so much high-resolution files. And when you play with IVAs, when you're using special machine vision cameras, you can actually set the frame rate per second for the camera. So, video is actually just a series of photos, right? Usually, your eye, as a very nice benchmark, your eye sees at 24 frames per second. So to be kiasu, you want to set it at like maybe 30 frames per second, or if you are even more kiasu, you can go all the way up to 60 frames per second. So that is really like super high speed. And when you're taking images at like 1080p or 4K, you're saving like 60 frames of 4K resolution or 1080p resolution per second and expect to process the whole thing in real time. That's a bit outrageous, right? So in terms of real-time processing, in terms of latency, this is the number one thing that gets compromised all the time, is that people have been trying to stinge on the quality of the quality of the input. Maybe they take fewer frames per second, maybe they just reduce the resolution of it, etc. So the latency usually, that's another thing to judge it on. So that's why I judge it on, at least. So yeah, just two things, very simply, and that's really enough for me to distinguish which is a better facial recognition company. So yeah. Okay, so back to the topic on models. So let's say I specialize, I am the world leader in facial recognition technology. Which companies, which industries should I approach? So one thing you'll notice is that a global trend for AI, when it first started, is that people were obsessed with face. Facial expression, facial recognition, and so on and so forth. And then the next thing they went into, which was a very, very hot industry, was surveillance. So surveillance in your home, surveillance in public areas, surveillance in real estate buildings, And then people started getting creative. They said, why not, let's do, using facial recognition and facial expression, let's go into retail analytics. Let's profile the consumers. So when they walk in a store, you can kind of like profile their things like age and gender based on, like facial features and things like that. All these kind of things is extrapolated based on the data you get. Using their own proprietary algorithms. So they've been very creative in terms of the industries they go to. So by possessing one model, in terms of one feature, you can already target a lot of various industries. So one thing we realize, that we observe in the AI scene globally is that people tend to stick to the model that they're good at and then sell it to multiple industries. And there comes the problem of a mismatch, because if I am an end client and I am, let's say, a security company like Cisco or something, I don't want just facial recognition, right? I want to go to a startup or a company and say, hey, I want to monitor a lot of things, the security of this area. I want you to do body posture recognition. I want you to do facial recognition. I want you to do facial expression recognition. I want you to do text extraction, object detection on whether they're carrying a luggage bag or a purse or something like that. And then like these startups, they're pretty much just focused on just one model. And you know, they're all scattered all over the place. So this big end client, you know, now they have to do their due diligence to go and find out, okay, body posture, which one's the best in the scene for body posture recognition, who's the best and everything. And that's problem number one. You know, it's all scattered around and they have to do their due diligence to search globally for that specific feature. And the next one is integration. So in terms of when you program on AI, you know, there are a few different frameworks that you can use. You might have heard of TensorFlow, you might have heard of Cafe, you might have heard of Torch and various other frameworks. So if you want to integrate all these together, you know, it's another pain to go through, you know. So in terms of adoption of AI technology, there is definitely a lot of hype, but not yet. Give it maybe another 1 year or 2 years before people are really ready to adopt. Right now, people are still excited about IoT. It takes a while for it to catch up. So yeah, I'll give you some examples of things that, you know, I've come across in terms of features. So the very beautiful thing about deep learning is that you can custom train models. So if you recall, Singapore had a rat problem last year at Bukit Panjang. So after Bukit Panjang, the whole rat problem thing, there was the rats moved to Bishan. And then ST Engineering contacted us and said like, okay, we are able to collect data of the rats in the gutters with thermal vision cameras that you hook under the drain cover, right? You can actually collect all the images of the rats and things like that. But I'm not gonna manually sieve through the images to actually count like, okay, this is rat number 1, this is rat number 2 for like, I don't know, 2 weeks or 3 weeks worth of data. So their goal was actually to identify which is the most frequently used tunnel by the rats and then deploy the poison, because to put poison everywhere is going to be very expensive, right? So it's better if it's targeted to the most frequently used one by the rats and also what time. So yeah, they installed the thermal vision cameras. We took the images, like 100,000 images, trained it to actually recognize that that is a Singapore rat. So Singapore rat, not German rat. So what are the features that we actually base it on? Maybe it's a tail length, the average kind of outlook of it. But by feeding okay, so you see, when the thing about AI is that you cannot say like, identify a rat, and then like, poof, magically, like it's able to identify the rat. You need to actually train a model out of it. So that's what we'll do. If we have time, I'll go through a little bit of the technical side on how something gets trained. But the thing is that you feed it with a lot of data for rats. One problem about data is that, you know, if you feed it an image, the first few images at least, you must label it. So within the image, you must actually say like, okay, this thing here is a rat. It is not two rats together. Like, you cannot assume that the computer knows that that is one rat, right? You must be able to label it and go like, okay, this is a rat. And then that is another rat. And then you go the next one, that's another rat, another rat, another rat. So just by taking pictures alone, right, it's very good to have clean and clear images, but then the next problem is like, how do you label the images? So like for 2 or 3 days, you're just staring at like 100,000 images of rats. Not very fun, but at least they're thermal images, so it's not that bad. So yeah, labeling your images. So we can do custom trained models. So let me give you some other examples, something fun. Singapore Zoo. So we got approached by Singapore Zoo to do this project. We are still in talks about it, on how do you differentiate Kiki the monkey from Coco the monkey from Kaka the monkey. So the idea is that behind each monkey, they have a story on how they got rescued and rehabilitated, right? So if you print it out on like a nice card and go like, oh, Kiki the monkey was separated at birth, and Coco the monkey is the brother of Kiki the monkey. It's like, even if the tourist reads it or like the visitor reads it, they're gonna look at that monkey as like, is that Kiki or is that Coco, you know, kind of thing. It's like they're unable to differentiate it. So the thing is, we're going to work with them to kind of like train it to recognize that, okay, this one is Kiki, this one is Coco, and that one is Kaka. So initially, as a proof of concept, you just take they have this mobile app, you take a photo of it, and then you're able to distinguish Kiki, Coco, or Kaka the monkey. And then if everything goes well, we have a transparent LCD screen. So like, you have like, let's say a raccoon enclosure with like 10 raccoons running around. If it runs in front of that transparent LCD screen, you'll be like, zoop! This is Emily the raccoon. Emily was rescued at birth from a forest fire in Australia, this kind of thing. So it's pretty fun. To be able to pick up the nuances that the human eye can't is also another plus for AI. Another thing is that to give you, these are very fun cases. Let's talk about more economic cases. So in terms of industrial manufacturing, Industry 4.0 movement, if you heard about visual inspection, so once you manufacture a component, let's say we have a client who manufactures parts for Boeing Airlines, when the components get manufactured, they must make sure that every single thing is accurate, right? You cannot afford it, it's Boeing. Or even if it's like electronics, a PCB board, a printed circuit board with like 100 chips on it. Right now, like this poor lady in the factory is just like inspecting, or like, oh, is that sorted? Okay, cool. And then like it's just like coming in real time, so there's a pressure to be like, okay, done, next one. If she just zones out for a bit, right? The accuracy of it, of the assurance, just because you have a person there is not very assuring. So with computer vision and deep learning, we are able to actually pick up all these kind of small nuances. So very funny. I was at one of the factories of one of the biggest silicon manufacturers in Singapore. They are listed. They walked me around the factory and they were like, okay, Annabelle, wherever you can see your AI technology being implemented, please stop me. And then I was like, sure. Because like right now there's already a machine that does that. It's not new technology for PCB inspection. It's not new, honestly. But it costs $700,000. Very expensive. So it's usually reserved for the manufacturing line that gets highest volume per day. Oh, okay. Yeah, either like high volume per day or the highest value. So they are like, okay, wherever you see, just stop me, because my board just cost $2,000. $700,000, $2,000. So they are like, okay. And I'm like, hey, can we implement it here? And then we stopped. And then the guy was like, very good. That means I don't need these two people. And then from inspecting the PCB board, they just looked up at us and I'm like, what? So I was like, no lah, we deployment somewhere, Singapore foreigner ratio and everything. Oh, come, let's go. And I'm like, right. So a lot of times, people think that, okay, AI is gonna like take over jobs and everything, but I think it's gonna complement in some ways, because in terms of education, right, we are moving to a higher level of education. No kid is going to go like, oh, mommy, when I grow up one day I want to be a PCB inspector. They're facing hiring crisis. Even like the young generation, when they grow up today, they don't want to do this kind of menial jobs. They want to do something more glamorous. So they're facing the crunch also. And also, we are complimenting them in terms of the accuracy that they perform. Because the thing about AI is that it can tell you what's wrong. But to fix the issue, you still need men on the ground, right? To actually unsolder the component and put it back, or actually to put it one side and actually do the fixes to it. Or let's say security, to be able to detect that that's a terrorist, and then to send a man down. Then you still need a physical guy. Ooh, speaking of terrorists, something very interesting. So, okay. In terms of security and AI, etc., so we talked about models, right? So if let's say the model is, I am able to detect that is an object, okay? This man's pose is like that, and this is a pen, and this is a mouse, etc. Very often, when you talk to the end client, they'll be like, okay, very good. Put all these models together, and you'll use it for terrorist detection. And you're like, huh? Okay, so do you want us to do the whole thing for you? Because it feels like you want us to do the whole thing. They will come to a point where they say, no, I don't want you to do the whole thing, because it's very controversial. How do you classify someone as a terrorist, right? Just because by skin color, just because the guy is, let's say, a darker shade of skin color, or maybe because he has like cloth all over the face. You know, all these kind of like rule-based systems, all this, the secret sauce behind it, they're not gonna tell you. Or even let's say for consumer profiling, like you have like 1,000 people walking in front of the board, the billboard. How are you actually able to say that, he is the one that's most likely gonna purchase my items from a mess or something like that? You know, all this secret sauce for the business logic, they're not gonna tell it to you. So even as an AI startup, one of the problems is that you don't know the problem statement of the industry, and they don't want to reveal it to you. How much time do I have left? 15 minutes? Okay, cool. Anyone, are you still okay? Can I go into a little bit more techie side of things? Okay? Yes, okay. Do you have internet here? Wireless at SG, okay. Okay, I'm just going to very quickly tell you how AI works in terms of the tech side of things. I'm not going to delve very deep into the various neural net models, but at least you kind of have an idea of how it works. Okay. Huh? My hotspot. My phone is in. Alright. Okay, cool. Now I'm just gonna make like, if my gestures hasn't been exaggerated, I'm gonna make more exaggerated gestures then. Okay? Okay, cool. Okay. Think of it as this. I'm going to do it facing you. So yeah, you have your input, right? Your input here, input layer, and then you have your output layer, right? So the idea is that I'm going to feed it with some information and get something meaningful out of the whole thing. So what happens in between, right? So I am like what we call the hidden layer, okay? So input layer, hidden layer, and output layer. So what we're looking at right now is a single layered neural network, right? You feed it with a layer of inputs, some processing happens, and then output. Why do I say layer and not thing? Because a layer actually can be several things. So let's say I want to make the perfect laksa, you know. I run a laksa shop. And then I was like, okay, what are the ingredients for laksa? Coconut milk, so you have coconut milk, and then you have curry, and then you have various other things, right? And then at the end of it, I want to get the recipe for the perfect laksa that everybody likes, okay? So that's my final output. So in the hidden layer, it does the processing. So now I'm gonna go one step a little bit deeper. Bear with me. You have weights assigned to the ingredients. So weights can also represent importance, right? So if let's say coconut milk, okay, we realize that the more coconut milk we add, the happier people are. So maybe coconut milk have a weightage of let's say 10 points. Let's say 10 points, and plus a combination of let's say 2 units of curry sauce, and maybe 3 units of lime leaves, etc. You know, you have now aggregation of this coconut milk times the units plus the lime leaves plus times its units plus the curry sauce times its units, right? So now you have the aggregated thing here. But that's only use case scenario number 1. What if, let's say I find this most appealing to me. What if somebody else likes something else, which is also made out of a product, some end product of the various ingredients, but maybe they place different emphasis on different units, right? So now you have the hidden layer, you have different possible outcomes. So it's kind of like, okay, yeah, there's this scenario here, and then you know, at the end of it, you just need one laksa recipe, right? So using the same concept, you can't have like this thing and this thing and this thing and this thing and this thing in the hidden layer, different options in the hidden layer. You actually compare with the final one, the final laksa that actually comes up. So okay, I think like, okay, now I have the perfect business model for the best laksa recipe. Using this, I start selling my laksa. And then I realize, you know, based on customer feedback, it's not 100% hit. Maybe I'm selling like 70% of the laksa and not like 100% of the laksa. So it'll be like, okay, I need to make some adjustments to it. So then again, it'll be like, okay, there is the difference between the actual result of the laksa, the actual one that we are expecting to happen versus my theoretical one. The difference is what we call the cost function. So taking this cost function, you can actually adjust, go back, trace it back, adjust the importance, the weights and to the various ingredients. You keep adjusting back and forth, right? So this is where we have the learning process happening. So taking it to the computer's context, we are not looking at just one single layer, right? When we're looking at facial recognition, facial expression, maybe one layer is the eyes, one layer is the nose, one layer is this, or maybe one is vaguely detecting the edges of the face, and then now it's trying to make sense of, let's say, within other than the edges of the face, you're looking at the edges of your eyes and things like that, features. So there are tons of layers in between, and the process, the idea of, comparing the actual data that you're expecting to get back and forth, you are able to adjust this process automatically without somebody actually doing it. So there comes the idea of supervised learning and unsupervised learning. So you can go and search up a little bit on it. Unsupervised learning is very interesting. But a lot of the times it's what we call rule-based. Never mind, ignore I said that. Just search up on the different layers of artificial intelligence, as in different layers of neural networks. So one thing I wanted to show you is that the different models that are available out there. So neural networks can get very complicated. Every day, maybe every day or at least every other day or every month, new kinds of neural network models are forming. So what I showed you is a very linear one, right? Like input layer, hidden layer, maybe 2 hidden layers, maybe 10 hidden layers, maybe 100 hidden layers, and then an output layer. But we have seen very recently some very disgusting yet beautiful in terms of artistic value. What neural net models look like. So there's this very famous thing, the zoo. Ta-da! So previously, right, I was talking about this neural network. It looks something like that, right? You have your input layer, your hidden layer, and then your output layer. So this is like my ingredients for laksa. With the arrows, I'm assigning weights to it. So you see, pointing to this hidden layer is actually a combination of all 3. It might not necessarily be all 3, maybe it's just 2 for some of them. And then based on all this, you kind of have the output. It can be 1 output, it can be 2 outputs, it really depends. And of course, you get more complicated ones like that later on if you want to add more hidden layers. It depends already on what is the kind of information that you want to process. So So this is a very linear-ish one. The zoo is pretty interesting. You get fun ones that look like that, and that, and that, and that, and that, and that, and that. So, depending on the kind of neural network model that you're using, you can really push the boundaries of it. So we have this thing called Generative Adversarial Network, GAN, where you are able to actually, so GAN is something very interesting. Okay, they didn't specify. Okay, so use case application for GAN is kind of like, I'm just going to feed it information saying that there is a girl in a black room holding a pen. And then they suddenly, based on this text saying that there is a girl in a black room holding a pen, they are able to actually come up with a visualization of a girl in a black room holding a pen. And what kind of pen, they will also just pick and choose one of them. So you generate, depending on the kind of neural network that you use, you are able to actually come up with different kind of results. Some would be predictive, some would be, historical analysis. Some will be various other things. So yeah, gun is pretty much. I think it'll be used very widely in VR and gaming initially. And then the joke that we have in the AI scene is that gun is only useful for one thing, porn industry. But never mind, ignore I said that. Keep it to yourself at least, as you do with all porn. So yeah. Okay, I think I'm running out of time, but I'll to very quickly summarize. AI is definitely a buzzword, but don't let it excite you. We are still the hype precedes the actual technological innovation that is actually happening. You hear a lot of talk about autonomous cars, you hear a lot of talk about what it can do, but the actual deployment of it, there is a lot of barriers that we need to overcome first. The most basic barrier to overcome is education, knowledge, in terms of the people who are gonna be implementing it. Because many a times you see...
Your attention, please. Help us make the library a conducive place for learning for all our users. Parents, please ensure that your children behave and are quiet in the library. Thank you, children, for not running, shouting, scattering books, or climbing on library furniture. Staff will request users who do not cooperate or misbehave to leave the library. Thank you for your understanding and cooperation.
So yeah, there are a lot of barriers to entry in terms of deployment of AI. So it's one thing to be an enthusiastic hobbyist who wants to learn about AI, but then you ask, what can I actually do with this technology? So if you are to get started on AI, I would recommend this approach that is the least, that burns your wallet the least, okay? So you want to try to invest as little money into it until you are comfortable. I'm talking from a hobbyist level, okay? Go and search for things like Google Vision API. Okay, Google. So these are open source stuff that you can just integrate within your code. So things like text processing, natural language processing, video analytics, object detection, all these kind of things. It's really simple. It's just an API. So once you are comfortable with playing the API, you get a sense of how it works and how it doesn't work. Then play with the cameras, because now that you're comfortable with the software, you want to have more control over the data that you are feeding into the software. So I'm assuming that when you're playing with this software, the Google Vision APIs and various API cloud services, you're using off-the-web images that you find or things. You're not really generating your own data, or even if you do, it's just like very basic level. So I want you to explore more into collecting your own data. So in this phase, you're gonna question yourself if you're looking into vision analytics. Is that, do I need an IP camera? Do I need a web camera? Or do I need to spend $1,000 on a machine vision camera? How far do you want to push the limits to? And then once you're comfortable with that, then I want you to look at building your own models. So,
dear readers, the library will be closing in 30 minutes. If you wish to borrow library materials, we advise you to do so now at our self-check machines. We thank you for your visit and hope to see you again soon.
Yeah. So the thing is that you play with your own models. You don't want to be so reliant on a secondary party like Google or Facebook, etc., on their APIs. You actually want to try building your own neural net, your own model, right? So that is a very challenging part. So it's really good if you have a strong foundation in C++ and Python. And then once you're comfortable with that, then you explore the hardware architectures of training it. So initially, all this training, I'm assuming you're going to use Amazon Web Services, etc. But once you're comfortable with that, you can look at building your own custom computer, or actually purchasing a various device specifically for training, or maybe specifically for deployment. So edge computing devices are pretty much deployment devices. To train it, you actually would buy like a NVIDIA Titan X or a graphics card or something like that and build your own computer. So that one's really a heavy investment. So don't go there yet if let's say you want to get started on AI. So when you build your own models, you are pretty much quite up there already. You can actually consider doing a startup based on AI, a software startup based on AI. So there's lots of possibilities. Right now you'll see that the security industry is very saturated. So I would urge you to be more creative, explore the various industries. So for example, retail industry. If let's say everyone picks up this object and go like, oh, very nice, this mouse is very nice, and they see a price tag, it's like, oh shit, it's $2,000, I'm not gonna buy it. You know, all this kind of analytics is not captured within the system. So how you would program AI software to actually capture this analytics is kind of like, first, I need to be comfortable with object detection model to actually identify that this is a mouse. And the next model I need to identify is that this is a person approaching the mouse. And how many people are, once you're able to actually identify that's a person, it's very easy for you to do the people counting, to say that, okay, there are 3 people around this mouse at this certain time. So object detection, people detection, if you want to push it one step further, you can do a profiling of the person, what's their reaction when they actually look at the mouse. And then from there, it's really just data extrapolation and basic data analytics, things like comparing this data with the inventory system to see whether it matches in terms of percentage. Like if let's say 100 people linger around this mouse in 1 hour, but there's only 1 sale, is there something wrong with it? So that's where the business logic will come into play. So yeah, if you want, you can check out some of the courses for deep learning online. There's a lot of resources. The most famous one would be the one by Andrew Ng, a Singaporean. Yeah, Andrew Ng from, yeah, huh? All right. Machine learning, okay, whoops. Yeah. So yeah, there are a lot of resources online. You can just do a quick Google search for it. I would advise you not to skip the basics. It does help if you have a mathematical understanding of how it works. And from there, it's gonna help with your entire deep learning process. Because if your basics is not strong, you're gonna have a hard time actually keeping up with the developments in AI, and it's moving very, very fast. So a strong foundation will definitely help. So I think I will end my talk here. So yeah, thank you.